So my presentation here at ESOC was about cognitive profiles after stroke. So what we actually looked at was, so generally speaking, a lot of research about post-stroke cognition focuses more on global cognitive impairment, or they focus on a single cognitive domain. And we thought, let's try to take a different approach to the research, because ideally you consider all of the information you have about a patient and you look at the entire cognitive profile, because that's also what clinicians typically do. And so we wanted to bring research closer together with clinical practical methods. And so we investigated to what extent patients can actually be classified into subcategories that are characterized by a specific cognitive profile. So we used a data-driven technique, which is relatively new. It's called latent class analysis. And using that data-driven technique, we derived several subgroups within the stroke sample that were characterized by specific cognitive profiles. Hopefully this is a first step towards readdressing questions about post-stroke recovery, functioning in daily life, and how it couples to cognitive impairment, because we're not looking only at global cognitive scores, but we're really looking at the specific cognitive impairments that a patient has. The best model that we obtained was a 13-class model. So it demonstrates that there's quite a large inter-individual variability in cognition after stroke. So that's a bit in contrast to what has been published in literature, demonstrating more low dimensionality. So our study results show more high-dimensional structure. Every detailed profile is a bit much to explain here. I think that's best to read the paper. We do see some classic examples of like a neglect profile, and like egocentric neglect profile, and an ego and allocentric neglect profile, and aphasia profile. Those kinds of classic findings are recovered in our data, but it goes beyond those things. And what was also interesting is that the profiles we identified, they were not associated to demographic features like age or gender, time since stroke, or country of residence, because it was a study across different countries. But it was associated to lesion size, which was the thing that we also hoped for. Our next step is to perform voxel-based lesion symptom mapping to really see whether lesion location itself is associated to the cognitive profiles, because at the moment we only looked at lateralization of stroke, but that's very global. So we want to really get a bit more insight in whether there's specific lesion substrates for cognitive profiles. And then ideally we would also, but that's a bit more difficult to accomplish, is replicate our findings with other cognitive tests to see whether it's something general or specific. And then also look at how profiles predict recovery and functioning in daily life. Our main question there is maybe we should consider cognition more as like a delicate ecosystem, and if certain parts are impaired, maybe it has a huge impact. Other parts might be less impactful. So maybe there are very specific cognitive comorbidities that make patients especially vulnerable for impairment in daily life, and that's something we would like to further examine.